Your smartphone runs on a 2300-year-old argument, Plato versus Aristotle. In the next few minutes, you will see how this ancient debate still drives the apps you use and the AI powers your world. Hi, I am Necati, a computer scientist with 20 years of experience, and on this channel, I share my experiences and thoughts. At the center of philosophy and computer science, more or less, there is one single question. How do we build a model of the world? Plato and his student Aristotle answered this in opposite ways. And those answers map almost perfectly onto programming and machine learning. Let's start with Plato. Plato said everything we see is an imperfect copy of a perfect, unchanging form. So I think it is better if I just give you an example. Let's assume you draw a circle. According to Plato, what you draw is an imperfect copy of a perfect circle that exists as a form. And that form has exact mathematical properties that no physical circle can fully achieve. That form exists independently of whether anyone thinks about circles. Now, let's map this idea onto software. Think about this. Before a machine executes anything, we design an abstract, unambiguous blueprint, which we call computer code. So the code comes first and then behavior. Behavior comes second. Actually, we see this philosophical view obviously in object-oriented programming. A class named car isn't a car. It is the idea of a car. That class has essential properties and behaviors. Only then we create the instances. So we have the class car, then we create the copy of that, create the instance of that class, which we call car. So that view reflects the Platonic view. That idea reflects the Platonic view. And we see this Platonic idea everywhere, like type systems, database schemas, interface contracts, compilers, even formal verification. We define the perfect blueprint before anything is allowed to happen. Now, let's talk about Aristotle's view. Aristotle said the truth is in particulars. So what he means is the truth is right here with us. What we observe is the truth. To understand cat, you don't meditate on perfect catness. You observe cats, lots of them, and then create the abstract idea of a cat from what you see and learn. You extract the common patterns and understand what a cat is. That is the philosophy behind machine learning. We don't just give the model a perfect definition of what a cat is. We feed it with thousands of examples, the real examples, and from this pile, it extracts patterns, which is the statistical model of catness. Machine learning is empirical, adaptive, and comfortable with ambiguity compared to regular software development. So, which approach wins? This is a debate, right? So, which approach wins? Well, both wins. And that is what makes the modern computing powerful. So when we think like Plato, that gives us structure and precision. When we think like Aristotle, it gives us intelligence and adaptability. Take self-driving car example. On the Platonic side, we have strict safety protocols, precise sensor interfaces. On the Aristotelian side, we have neural networks that learn to recognize pedestrians and traffic patterns from millions of examples. Or consider the LLM systems that we have right now, the architecture, transformers, attention mechanism, training loops, that's pure Platonic engineering. But the knowledge that comes from observing examples, millions of, billions of examples, and that is the Aristotelian view. I tried to show you computing from a different perspective. Think about this. What we have now, all this tech, is the output of human thought. And that process didn't start with someone coding. It didn't even start with a mathematician solving a problem with a pen and paper. It all started with those philosophical questions about how we understand the world. This 2300-year-old debate isn't just philosophy. It is the blueprint for how we build the systems today. See you in next video.